Hello, everybody. Welcome back. Got office hours tonight. Let me just get my webcam pointing correctly. Hope everybody's studying is going well, right? We got the big day tomorrow morning. So let me know who's here. Say hi in the chat, and then we'll get started in a few minutes. Hello, Jared. Navik, right on time. Jax, good to see you. Will and Logan, welcome, welcome. That practice exam was really helpful. I'm glad you found it helpful. Yeah, that was an old exam, so kind of give you a sense for what you're in for tomorrow. I wish my webcam was a little more stable, because that could have been a really good video if I had a better webcam. But what can you do? I think it got the job done at least. All right, we'll start in, I don't know, oh, James is here a little early to the sip, starting at 6. Hello, Jack. Hello, Max. But yeah, so once 6 o'clock comes around, let me know what types of questions we should work on tonight. Josefa, is the exam going to take the full 3 hours? I mean, it might. The people who do it quickly will probably finish in an hour and a half. All right, well, it's 6 o'clock. Let's get started. Well, I don't know what that means, but let's do the simultaneous sip one last time. Hello, Rena and Ellie. Good to see you. Isabella and Nicole, hello. Okay, so if you have I hope it's not coffee, your water or your milk or wine punch or whatever, would like to join in the simultaneous sip, now is the time to do so. All right, let me see in the chat. What are we sipping today? Brewed some coffee just for this. It's too late for coffee. Growing the board, I see. Oh, beard. Growing the beard. A little bit. Water sip. Excellent choice for before an exam. All right, so late night tea, it seems like. Water for Jared. All right, so let's see, what do people want to talk about? Sip water, tea. Water's all around, it seems like. Yeah, good choice. Water and tea. FTC problems, velocity acceleration problems. Sure. Are there particular examples you want to go over? Is there like a specific question from the text or old quiz, or should we just make one up? Just make one up. All right, so we can do a question that's like, so this will use FTC1. All right, FTC2 we use all the time when we're just plugging in the endpoints when we finish, when we're evaluating an integral. All right, so FTC2 is like find the antiderivative and then plug in the endpoints to find what the actual integral is. FTC1 is the one that I think is a little bit trickier. So let's just make one up. So let's say find the derivative of the integral from, I don't know, let's say cosine of x to x squared plus 5 of, I don't know, the square root of 3t squared plus 1 dt. So basically what I'm saying is find what the derivative of, another way to write that, find the derivative with respect to x of this function. Okay, so we want to find the derivative of this function. Or find the derivative of this function, I guess. So how do we do this? Do I know about MVUE? No, what's MVUE? So either tell me in the chat how to solve this problem or tell me in the chat what MVUE is. Flip the bounds of a negative. Place 2 to x. Right idea. Yeah, you're on the right track, Greg. But the first thing we need to do is break up our integral, right? Because we only know how to deal with these derivatives when we could talk about that later, Emilio, but that's probably not relevant for our exam tomorrow. What we want to do is we want to take our interval. We want to have one of our bounds be a constant and the other one could be a function. And then we could use FTC1. So let's break this up. And it doesn't, I typically use 0 as the spot to break it up at, but it literally could be any number. Okay, so we could rewrite this as the derivative of cosine of x to 0 of the square root of 3t squared plus 1 dt plus, so it's the derivative of all this, the integral from 0 to x squared plus 5 of the same thing. Right? And now we want to have a constant on the bottom and a function up top. That's when we're allowed to use the fundamental theorem of calculus, part 1. So we want to flip this integral. And when you flip the bounds of an integral, it comes at the cost of a negative sign. Oh, well, thanks for stopping by, Emilio. Glad that you like the content. So when you switch the bounds of an integral, it comes with a negative sign, and now we're ready to actually solve the problem. Okay, so the derivative of an integral is just the inside function. We're going to replace all the t's with cosine of x. And then we have to multiply by the derivative of cosine of x. and then plus, I don't have space here, so I'll just write it below. Again, we're going to replace all the t's with x squared plus 5. And then times the derivative of this function. Okay, so what we were doing, what this last step is using the chain rule here. Are we happy with that type of question? So the key here again is break it up. The 2x came from the derivative of x squared plus 5. So we substitute our function in for t, and then we have to use the chain rule still. So that's times the derivative of the function. That's where negative sine of x came from. Where does the derivative go? So when we take the derivative, right, the derivative kind of cancels out with these integrals. Can we do the integral with absolute value? Yeah, we can do one of those also, but first we'll do a velocity and acceleration type question. Yeah, so so going from here to here, right? We're taking the derivative of an integral. That's where it went. Right, the derivative of an integral is the function, but with the appropriate bounds plugged in. That's what FTC1 says. So going from here to here, this is where we use FTC1. Okay, so I think somebody earlier asked for a question with volumes and, with velocity and acceleration. I can't see that far up in the chat anymore, so whoever asked that, can you just clarify what type of question you're looking for? Late SIP. Well, better late than never. Similar to the release final exam YouTube video. Sure, we could do one of that. Logan asked to use FTC1 when you need to take a derivative of an integral. Okay, that should scream to you. Use FTC1, because that's what FTC1 tells us. It tells us how to take the derivative of an integral. Okay, so if there's a question that's like, find the derivative of this function, and the function is an integral, then FTC1 should be used. Okay, so that had, let me get the test. Okay, so we had some position function, and okay, so some things that are important to remember is the derivative of position gives us velocity, and the derivative of velocity gives us acceleration. Okay, and then the steps obviously reverse. So the antiderivative of acceleration gives us velocity, and the antiderivative of velocity gives us position. Okay, so let's do a question that will both answer Isabella's question and Will's question at the same time. Let's see how this goes. Okay, so let's say v of t equals t squared minus 5t plus 6. Okay? Delayed sip. Okay, so our velocity is this. Okay, find the total distance traveled on the interval 0 to 6. Okay, so don't give me the full answer right now, but in the chat, what calculation do we have to do to find the total distance traveled? Antiderivative. Okay, we want, so integral would be what we want to do, but the integral of what? What function do we want to? Yes, Isabella caught on. I said we were going to do both a question that helped her and Will at the same time, and Will asked for an absolute value integral. So, I mean, I'm sure you actually knew this without the hint, but yeah, we're going to evaluate the integral. Remember, the total distance traveled is the integral of the absolute value of the velocity. Right? Because if I'm moving forward and then I'm moving backwards, that distance should be counted both times. Right? If I run to school and back, the net change in position is 0, but I traveled, a couple of miles and then a couple of miles back. So we want to count how far did we go forward, how far did we go backwards. So the total distance traveled is the integral from 0 to 6 of the absolute value of v of t dt. Okay, so how do we deal with the integral of an absolute value function? Right, how do we evaluate the integral from 0 to 6 of the absolute value of t squared minus 5t plus 6? Find where it's 0, and then split it up at those points. Yeah, and by treating it like a piecewise function. Yeah, I like all the answers. So let's find where it's 0, and I'm hoping I picked good numbers here. I was making this up on the spot. So let's find where it's 0. So let's hope this factors like I thought it did. Yeah, okay. So we get t equals 2 and t equals 3 as when it hits 0. And so what we'll do is we'll take our number line, which goes from 0 to 6, and break it up along the way. And we want to check, is our velocity function positive or negative on these intervals? Okay, so if you plugged in a number, let's say 1, you would get 1 minus 5 plus 6. That's a positive. If you plug in a number like 2.5, you could check it will be a negative. So calculator for that one. And then if you plugged in a number like 4 or 5, it's going to be a positive. Okay, so we could express v of t as a piecewise function. it's t squared minus 5t plus 6 on this interval and this interval. Sorry, the absolute value of v of t is equal to t squared minus 5t plus 6 on the interval 0 to 2, negative t squared minus 5t plus 6 on the interval 2 to 3, and then t squared minus 5t plus 6 on the interval 3 to 6. Okay, so to find the total distance traveled, we're going to evaluate the integral from 0 to 2 of t squared minus 5t plus 6 plus the integral from 2 to 3 of negative t squared plus 5t minus 6. And then last would be plus the integral from 3 to 6 of t squared minus 5t plus 6 dt. And I'm not going to evaluate those, but you guys know how to evaluate these, right? It's just the power rule. Add 1 to the exponent and divide by the new exponent. Add all those numbers up. In each of these sections, these should all be positive numbers. So that's a good way to check that you did it right. That's about as hard as you'd get for these like application type problems. We didn't spend a ton of time in class doing them, so don't. I think what I did on the YouTube video is probably harder than what you'll see. It was a weird semester. We didn't really get to go through everything I would have liked. Are we happy with this question? Okay, just thought of this one. Approximate tan of 59 degrees with a linear approximation. Okay, we could do that. Okay, so yeah, this is a little tricky because we never really talked about how do we take the derivative of trig functions when they're expressed in degrees, right? Our rule of like the derivative of sine of x is equal to the derivative of sine is equal to cosine of x. That's in radians. So we're in degrees here. So we can either just switch this to degrees and just don't worry about what happens when we're in degrees, or we could figure it out, figure out what the rule would be when we have degrees. So what do we think we should do? Should we switch to radians, or should we stick with degrees? We'll get the same answer either way. what is the preferred method? I mean, I personally would switch to radians just because you don't have to worry about the spoiler alert. What we have to do is just remember there's a chain rule. We'd have to use the chain rule. So it would be like the derivative of sine of x degrees is going to be cosine of x degrees times, this, how you would write degrees in terms of radians. So times there are pi over 180 degrees for each radian. So we have an additional factor of pi over 180 we have to deal with. Let's switch to radians so we can see that this question is actually pretty easy. Okay, so really this is asking us to approximate tangent of 59 pi over 180. Okay, so we know our function f of x in terms of radians is tan x. We need a. What value do we know that's close to 59 pi over 180? So what can we use for a? Yeah, pi over 3, right? 60 pi. I mean, it's easier to picture it this way. We would know tangent of 60 degrees. A is equal to pi over 3. Okay, so we need f of a. F of a, what is tangent of pi over 3? So in the chat, tell me what tangent of pi over 3 is and secant squared of pi over 3. All right, so correct me if I'm wrong, but I believe the tangent of pi over 3 is square root of 3, and this would be 1/4. Okay, so give me a fact check on this one. Sometimes I forget my unit circle. Tan is right, still checking secant squared. Okay, good. Okay, so we could now kind of wrap this up. Tangent of 59 pi over 180 is approximately equal to what? So how do we, given this information, it's f of a, so square root of 3, plus f prime of a, which is 1/4, (59 pi over 180 minus 60 pi, or pi over 3, so 60 pi over 180. And so we know it's approximately equal to square root of 3 plus pi over whatever 18 times 4 is 720. Sorry. Negative. Oh, Yes, Jax, you're correct. You see, that's the. Yeah, that's why you try to prepare your answers in advance. Yeah, so let's search this. No big deal. Nobody saw that. All right, try that. I like that answer better. All right, come on. You know, I'm a human. I do make mistakes, everyone. Often. Yeah. See this. By the way you should have known instantly that I was wrong. Thanks, Greg. Is the smallest secant can be. Secant of anything could be is 1. So when I wrote 1/4, you should have been like, you know, it's not going to be 1/4 because it can't go between -1 and 1. Yeah. So yeah, with these, if you were asked to approximate the value of some trig function, yeah, we could do that right now. If you're asked to evaluate the approximate the value of some trig function, just switch to radians first, so you don't have to worry about the chain rule when taking derivatives. Okay, can we do a problem where you check if a function has at least 1 root and no more than 2 roots? Yes. All right, let's just do a kind of an easier one, just because I don't know how to make one up on the spot. Okay, so let's say we wanted to show that this function has exactly 1 root. Okay, so in the chat, how do we, like, what tools do we use to show that a function has exactly 1 root? Yeah, we're going to use the IVT to show there's 1, at least 1. And then MBT will tell it, well, we're going to use the MBT in some sort of creative way to show that there can't be 2. Okay, so what do we need? What types of polynomials? Oh, okay, sorry. What types of functions can we use the IVT and the MBT on? We need continuous functions to use IVT, and we need continuous and differentiable functions to use MVT. But our function here is a polynomial, so it's both continuous and differentiable. Okay, so again, it's important to tell the reader, which is me, that our function meets the conditions necessary in order to use these theorems, right? So you would say here our function is a blank type of function, so here a polynomial, or maybe it's a radical function, rational function, whatever it is. You'd say it's continuous and differentiable, so we could use IVT and MVT. Okay, so how do we use the intermediate value theorem to show that f has at least 1 root? No, so negative infinity to infinity is perfectly fine for the bounds, Jared. on this whole graph, it's only going to cross the x-axis once. Is what we're going to prove. So yeah, if you're not given bounds, we still got to find a root somewhere. So it's going to take a little bit of thinking, but it's all right. You guys are college students. We can think every once in a while. So what's a good place to start, right? Because I think the idea, a lot of you guys know this, is we want to find for it to cross the x-axis, it has to go from positive to negative or from negative to positive, right? And then somewhere in between, it must cross the x-axis. The derivative. We're going to use the derivative eventually, but that's not going to help us find where it crosses. Yeah, so we'll start by plugging in 0. It's like 0 is a good place to start, right? The root is either to the left of 0 or to the right of 0. So let's try 0 and then kind of get a guess. Yeah, unfortunately, Greg, factoring is probably not going to work. Let's start with 0, and then we'll just kind of have to kind of guess which side of 0 we should try to look for the root on. So f of 0 equals 1, which is greater than 0. Okay, so we have a positive. What can we plug in for x to get a negative number? Like, what can we plug in for x here to make this expression negative? We have x to the third plus 2x plus 1. We want to make this negative. -2, -1. Either of those will probably work. -100 would also work. So let's just try let's say -10. Just to really exaggerate it. We don't really care. We don't care what the root. We don't care where the root is. We just need to find it. Find, a kind of a range for where it could be. If we plug in -10, we get -1,000 minus 20 plus 1. So that's negative 1019, which is definitely negative. So f has a root between between -10 and 0. Right. So this is by the IVT. And you could have picked the other smaller intervals, like what Jax or Will recommended. That's also fine. I wanted to really just exaggerate it because it doesn't matter. Okay. So we showed it has f has at least one root, right? It's somewhere between -10 and 0. Again, we don't care what the value is. We just know it exists somewhere there. How do we show f can't have two roots? Right? Because we want to show, we said it has at least one root. Now we're going to show that it has at most one root. And then that will imply that it has exactly one root. Could we also find critical values and find where the function goes from positive to negative or vice versa? Like from increasing to decreasing? Might work, but there's going to be cases where it's going to get a little too confusing. I would stick with this strategy. F prime of C formula, proof by contradictions, and say there are two roots, and then we're going to disprove mean value theorem. Yes, so combine Jared, Jackson, Nicole. That's going to finish the question off for us. So we'll let A and B be. We'll say, suppose there's two roots. We'll call them A and B. Okay, so we'll say, suppose that f crosses the x-axis twice. We'll say at position A and position B. So for them to be roots, that means f of A equals 0 and f of B equals 0. And now we'll use the mean value theorem. So by the mean value theorem, there is a number c in the interval a to b such that f prime of c equals f of b minus f of a over b minus a. Right? That's what the mean value theorem says. Okay. And well, f prime of c, that's going to be 3x squared plus 2, or 3c squared plus 2. That's the left-hand side. And the right-hand side will become 0. In what other cases would we use MVT? So that could be used to kind of give an upper bound or a lower bound for the value of your function. This was like our main application, though. And then we try to solve this. This has no solution, right? And so, yeah, definitely write out the reasoning if this is a question on the exam. So this has no solution, so that is a contradiction, so there can't be 2 roots. Would we always want to set f prime of c to 0, or can we use the values that we get from the interval AB? So it's always going to be 0 because we're picking these roots because we're saying A and B are roots. And what does it mean to be a root? It means that f of A equals 0, and similarly f of B equals 0. So this right-hand side will become 0 minus 0 over B minus A. 0 divided by anything is 0. But like we could generalize this. We're not going to. Don't worry. We could generalize this to some more complicated type examples, where like we could say, show that this curve only intersects the line y equals x once, and we would do the same kind of idea. It's probably too hard for Calc 1 class, but you know, something you could see down the line. Can you do an area under the curve problem? Yeah, do you have a specific example, Josefa? Can you make one like number 4? And I'm assuming when you say the video, you mean the final exam video? Yeah, let me take a look. Okay, so this is find an expression for the area under the curve. Let's say the curve is y equals x to the third, and our interval could be, let's say, 0 to 10. Okay, and we want to express it as a limit, and then we're gonna use an identity to evaluate the limit. Okay, and the identity is, which I would provide to you, so don't worry, I'd provide you this identity. Is n squared times n plus 1 squared over 4. Okay, so how do we do this problem? What bits of information do we need? You guys got to admit that video got quite a bit of views. I think it's got 200 views already. That's pretty good for me. Yeah, you need delta x and x of I. And we need f of x of I. Yeah, good. So we get delta x by doing b minus a over n. X of I is a plus I delta x. And f of x of I guess is 1,000 I to the third over n squared. Sorry, n to the third. Okay, so to find the area, to express the area under the curve as a limit, we would write a equals the limit as the number of rectangles goes to infinity, the sum from I equals 1 to n of f of x of I times delta x. Sorry, delta x is, there's no I. Okay, so that's the area expressed as a limit. And then the second part of the question would say something like evaluate the limit. Okay, and so to do that, we'd factor out all the constant terms. So that's a 10,000 over n to the fourth. Times the sum from I equals 1 to n of I to the third. And this is the same thing as this, right? That's where we're going to use an identity. Okay, and then, oh, sorry, this is a limit. All right, and this is just a rational function. The degree of the numerator is 4. The degree of the denominator is also 4. So we can evaluate this limit by just dividing the leading coefficients. I lost a 0 here. Okay, so when you divide leading coefficients, it works out to 2,500. And so now my question is, how do we check our answer? Let's say you do all this work and you want to make sure you get full credits. How do you check your answer? Yeah, so we just evaluate the integral from 0 to 10 of our function and hope we get the right answer. Yeah, so it'd be 10 to the 4th over 4, which is 2,500. Yeah, so there's no reason to not check your answer. You should have. I mean, you have 3 hours. The test is not that long. So you should make sure you go through and check all of your answers. When you finish. I know so I'm anticipating tomorrow that Canvas is going to just be annoying like it has been for the past few exams. So if it hits 12 o'clock and Canvas isn't working for you, just shoot me an email saying that you're working on uploading it, just so I know that you actually took the test and stuff. How many questions are there? I think there's 19 or 20 questions. It's very similar in length. It's very similar in length to the leaked final that I posted on YouTube. A few of the questions have a couple of parts, but there's a lot of one-parters. Oh, no, it opens at 9. Yeah, 9 to 12 is when it opens. Arrow is when it's open. It's not posted on Canvas yet, but you'll see it in the same spot that you saw the previous exams. Could you do a problem finding k in a piecewise function? Yeah. Yeah, let's do that. So you're saying like about find the limit from the left, find the limit from the right, and show that make it so they're equal. All right, I'll find a question similar to 1 and 15 from practice exam. Similar to 1 and 15 from the practice exam. All right, I think I'm looking at the wrong documents. Oh, from the study guide? All right, I think I know what you're asking. I don't know what questions you're referencing, though. Okay, well, I think I know what you're talking about, Nicole, but I'm just going to find a question in the book. Okay, you know, actually, I'm not going to find a question in the book. I'm just going to make one up. Okay, so we have a piecewise function. Let's say it's like x squared minus a, and so this is where x is less than 2, and this is x plus 3a if x is greater than or equal to 2. Oh, okay. Will typed it in. So we could do this one, and then we'll do what Will said, and that will be good. Okay, so try to find a value of a that makes this work, to make this continuous. And then the one that he said was x minus 2 if x is less than or equal to. X minus 2. Okay. So I think I wrote those questions down correctly. Here, let's hope this one works out nicely. Right, we want the limit from the left to equal the limit from the right, and f of 2 to equal those limits. So the limit as x goes to 2 from the left of f of x is equal to 4 minus a. Okay, and then the limit as x goes to 2 from the right of f of x is equal to 2 plus 3a. Okay, and so we want these to be equal for our function to be continuous, right? We need the limit to exist. And so for the limit to exist, the limit from the left equals the limit from the right. So 4 minus a is equal to 2 plus 3a. You get 2 is equal to 4a, or a is equal to 1/2. Right? And then over here, we're going to do the same idea. We'll do the limit from the left. And we get 5 minus 2, which is 3. If we do the limit from the right, you get 5k minus 3. And now we'll set these equal to each other. Then you get k is equal to 6/5. Are we happy with those? If you have a question during the exam, should we? Yeah, just send me an email if you have a question during the exam. I'll be checking it constantly throughout the time. And like if it's hard to explain via email, just say I would like to Zoom, and then I'll send you a link to Zoom, and we could chat over Zoom. I'm not going to just sit with an open Zoom thing the whole time because then I won't really be able to use my computer. All right, I think I think that's a good place to wrap it up. You guys will do fine. Okay, just take a deep breath. Don't be nervous and take your time. It's not a race. Okay, you have plenty of time. 3 hours. Just be calm. Okay, you'll be fine. It's exciting. The semester's over. I don't know what else to say. I guess remember, smash the like button before you get out of here. It's good luck for the final, they say. So might as well get the good luck. But yeah, I'll stay around to answer any last minute questions. But I think this is a good place to wrap it up. No problem. It was a fun semester. A little bit weird with the online thing, but think of the growth of my YouTube channel. That's the big benefit of all this. All right. Well, I'm going to end this now. Bye-bye.